All right, we're going to do a second day of the chain rule. So first thing we're going to do here is find the second derivative. So I don't think we've done a problem where we've done the second derivative, but basically that is the derivative of the derivative. So we're going to start by finding f prime, and then the second derivative is f double prime of x. That's how we'll denote that. Okay, so step one, first derivative, f prime of x is equal to, our outside function is the power of 3. So we're going to multiply by 3, which is 12. We're going to keep the inside part the same, x squared minus 5, and we're going to subtract 1 from the exponent and get squared. Then we're not going to forget to do the chain rule where we have to multiply by the derivative of the inside, which is 2x. Okay, and then I want to rewrite this by multiplying the 2x times the 12, so 24x times x squared minus 5 squared. All right, second derivative, f double prime of x. Okay, so now we have a product. So this wasn't considered a product because the number in front was a constant, but now the thing in front is a function. So we have our u and our v, if you like that notation that we've seen before. Okay, and so for f double prime, we're going to do u prime. So that's 24, derivative of u, multiplied by v. So we're not doing anything to this. We're just copying it down, x squared minus 5 squared. Then plus, then we're going to keep the u this time, 24x, and now we're going to do v prime. So we're going to multiply by power rule, 2 times x squared minus 5 to the first power, so I don't need to write anything there, and then chain rule multiplied by 2x. All right, so there's our answer. Let's see what we can do to clean this up. All right, so nothing in the first term. I'm just going to leave that alone. All right, so the 2x and the 2 and the 24x, we can multiply all those together. So that's going to be 2 times 2 is 4. 4 times 24 is 96. And then x times x is x squared. And then we also have our x squared minus 5. All right, I'm going to keep on going until we have something that looks a little simpler. So this is a binomial. We have a term here, and we have a term here, separated by our plus sign. So these two terms have something in common. They both have an x squared minus 5 in common. All right, so if we take that out, I'm going to use a bracket, but I'm just distinguishing because I'm having multiple sets of parentheses here, so that's why I'm using a bracket instead. So now I have 24, and I still have one x squared minus 5 left over, and that one. And then here I just have the 96x squared. All right, so I'm going to distribute in there a little bit and see what I end up with. All right, let's do that one. All right, so I have x squared minus 5. And then I'll just go back to regular parentheses, distribute. So 24x squared minus 5 plus 96x squared. And I should be able to finish this up by combining like terms. So I end up with x squared minus 5 multiplied by 96 plus 24 is 120. X squared minus 5. That's okay. And then you could go one step further. 120 and 5 are both divisible by 5. So I could take a 5 out to the front. X squared minus 5. 120 divided by 5. Let's see. 2, 4, 24. X squared minus 1. Okay, I had to pause the video because I was pretty sure I made a mistake somewhere, and I found it. So I need to go back to this step right here. Hopefully you caught this mistake as you were watching the video. I'm distributing the 24x squared. I did fine there, but I did not go to my 5 there. So instead of having a minus 5 in here, I'm going to have, what's 5 times 24? 120? Yeah, so I'm going to have a 120 right there instead. All right, and so when we do that, that'll give me x squared minus 5, and then this will be, still do our combined like terms, it'll be 120 x squared minus 120, which I can then factor out the 120 to the front, leaving me with x squared minus 5 multiplied by x squared minus 1. Okay, if you want, you can keep going. X squared minus 1 is a difference of squares. So x squared minus 5 and x plus 1 and x minus 1. Okay, this would probably be the usual place to stop as far as simplification goes. Okay, as far as the AP exam is concerned, if this is a free response problem, this answer right here is just fine. You do not have to ever simplify on the free response on the AP exam. Okay, but if this were a multiple choice question, it's going to be simplified. So you still need to practice going through the process. Okay, I would even say we could take it one step further. This is a difference of squares. Now it's a weird one because it's not a whole number like x plus 1, x minus 1, but you can still do it because it's a minus sign. So this would be like the fully factored form. You would get x plus the square root of 5 times x minus the square root of 5 times x plus 1 times x minus 1. So that is your fully factored answer right there. Okay, so just depending on the context of the problem, you may want to go all the way to this factored form because we can easily see what the zeros are of this second derivative. And that's something that you will need to be able to use in future problems. Okay, if all you're doing is the whole problem is find the second derivative like it was on this one, we could have stopped right here. Okay, so it just kind of depends on what you're using the second derivative for. If that's the final answer, stop as soon as you can. If you have to use the second derivative to do something else later on, then you probably want to do some simplifying. All right, find the points where f has a horizontal tangent. Okay, I think we talked about this in a previous problem, but if not, this is where f prime is equal to 0. Horizontal lines have slopes of 0, and so the slope of f is f prime, and we set it equal to 0, and we can find the points where that happens. All right, so step 1, find f prime of x. Quotient rule. So we're going to do low. I'm going to rewrite this in exponent form to the 1/2 power d high times 1 minus high, which is x, and then d low. So I'm taking this 2x minus 1 to the 1/2 and putting it through a derivative. So multiply by 1/2, keep the inside part the same, subtract 1 from the exponent, so negative 1/2 now, and don't forget about your chain rule. Multiply by the derivative of the inside, which is 2. All right, then all of that is divided by 2x minus 1 to the 1/2 power squared, the denominator squared. Okay, so first term, since we have to do something else, we have to set this thing equal to 0 and solve it. Simplifying is going to be a very important thing here. We definitely want to simplify this as much as possible before we set it equal to 0. Okay, so multiplying by 1, we can just get rid of that 1. 2x minus 1 to the 1/2 power. All right, I have a negative exponent, so I'm going to put that on the denominator, but not this denominator, like its own denominator. The 1/2 and the 2 can actually cancel out. So I'm going to have an x on top right there, and I'm going to have a 2x minus 1 to the 1/2 power there. Then on my big denominator, power to a power rule, those exponents cancel each other out. So you're left with just 2x minus 1 down there. Okay, now still not simplified enough for me to be able to solve. This is a complex fraction. So now I'm going to multiply by this denominator so I can cancel out the complex fraction. And so I have to do the same thing down here. All right, so distribute this all the way over right there. Multiply like bases, you add their exponents together. So that ends up just being 2x minus 1 to the first power. So I don't need to write that. Here, distribute to this, that cancels out, and you're left with minus x. And then here, multiply them together, you get 2x minus 1 to the 3/2 power. Power of 1 plus 1/2 is 3/2. So my simplified form will be just x minus 1 on top, combining my like terms, over 2x minus 1 to the 3/2 power. Okay, now that we found the derivative, we can answer our question. Okay, so the question says find the points where f has a horizontal tangent. So f has a horizontal tangent where f prime of x, which is equal to this thing we just found, is equal to 0. Okay, and when you want a fraction to be equal to 0, you want the numerator to be equal to 0. And that gives me an x value of positive 1. Okay, now notice it said point or points. Okay, we're only going to get a singular point here, but that means points means an x and a y, a coordinate point on a graph. So once you found the x value, you're now going to plug that in to the original function. We're finding f of 1. So that's going to be a 1 on top, square root of 2 times 1 minus 1. That's 2 minus 1, which is 1. Square root of 1 is 1. 1 divided by 1 is 1. So we have the point 1, 1, and that's it. So we can write our answer. That's what we were trying to find. All right, let's look at the next one. G prime of x given that. Hey, this is a chain rule problem. Give it a try on your own, and then unpause the video, see how you did. All right, G prime of x is equal to, we do the derivative of the outside first, f prime, keep the inside the same, and then we multiply by the derivative of the inside. Not really much else we can do with that. So that's it. All right, over on the back. So now we're given a graph. This has two functions on it. We have G, which is the bold function. F is the less bold function. We're going to use the graphs to find the following. So these are very popular AP exam style questions because they really force you to use the rules, the product rule, the quotient rule, the chain rule. Whereas if they give you actual functions where they tell you what they're equal to, you could find ways to get around doing the actual rules, especially if you're on a calculator part of the test. Okay, so h prime of 1. So h prime of 1. So anytime we see an x, we're just going to plug in a 1. This is a product rule. So this is f prime of 1 times g of 1 plus f of 1 times g prime of 1. Okay, now we're going to use the graph to find all of these things. So f prime of 1 is the slope. So here's x equals 1 right there. So this is the point we're focused on, and that happens to be the same point on both graphs. But for f prime, we're looking at the slope. So what's the slope of this line right here? Rise over run. Looks like my slope is positive 2. G of 1 is just the y value, 1, 2, 3 right there. F of 1 is the y value, so that's also 3 right there. And then G prime of 1 is the slope of the G graph right here. So it looks like that's a slope of negative 1. So we end up with 6 minus 3, which is equal to 3. All right, K is the quotient rule. So K prime, and this time, anytime I see an X, I'm going to put a 6. So I do low, G of 6, D high, F prime of 6, minus high, F of 6, D low, G prime of 6, all over low, G of 6 squared. All right, back up to our graph. 1, 2, 3, 4, 5, 6. So there's one point, looks like that's at 2. Here's another point, that looks like that's at 4. And then we can do the slopes as well. Okay, so G of 6 is my first one. G is the bold one, that is 2. F prime of 6. F is the less bold one, so that's this. And I want the slope of this line for F prime. Down 1, right 2, negative 1/2. Minus F of 6. F is the less bold one, so that is 4. And finally, G prime of 6 is the steeper one, negative 2 over 1. So negative 2. That's all over G of 6, which we already found was 2. So that's all over 2 squared. All right, so this is going to be negative 1. 2's cancel. And this is going to be positive 8, so plus 8 and then we get a 4 on the bottom. So that's 7 over 4. All right, a couple more. Next one is a chain rule. So p prime of 6 is equal to, we do the derivative of the outside first, keep the inside the same, plugging in 6 for x, and then multiply by the derivative of the inside with the 6. All right, so first thing I'm going to do is find g of 6, which we just had on the last problem. G of 6 is equal to 2. So this is f prime of 2. And then g prime of 6, we also did that on the last problem. That's this number. There it is, negative 2. Okay, so now I need to find f prime of 2. I haven't done that one yet. 1, 2, right there. All right, f is this, and it's that point right there. All right, we run into a problem here. On the left side, we have a slope of positive 2. On the right side, we have a slope of 0. That's a sharp turn. So this function is not differentiable. So this does not exist. And then our reason is because f prime of 2 is undefined. Let's write that a different way. Let's say because f is not differentiable at x equals 2. All right, one more. T prime of 7 is equal to g prime of f of 7 times f prime of 7. All right, 7 up here, right here. There's a point. There's a point. Okay, so I need f of 7. F is this one right there. Looks like it's at 3.5. Okay, so this is equal to g prime of 3.5. And then f prime of 7 is the slope of this line right here, which we found earlier when we did this point, is negative a half. All right, so g prime of 3.5. Okay, so 3.5, that's right here. G is this function here in the middle. So I want the slope of this line. Rise is 2, run is 3, 2/3. So that is equal to 2/3. We're multiplying by negative a half. You can cancel out the 2's and get your answer of negative 1/3. All right, hope you enjoyed, and I'll see you on the next video.